So right now I want to talk about section 0.7, quadratic equations. So specifically, I'd like for you to look at exercises 5, 9, 15, 19, and 31. The big thing that you probably already know is a quadratic formula. I'd also like you to know some things about parabolas. Let's call it parabola facts. Okay, so first, let's write down the quadratic formula, although probably a lot of people already know it. If we have that ax squared plus bx plus c equals 0, then we get that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you know some fun songs, whatever, but this is the quadratic formula. So this is the quadratic formula. I would definitely recommend reviewing this if this doesn't seem familiar to you right now. I'm going to, again, assume that you've at least seen this before. Even if you're not an expert, I'm just going to assume that you've at least seen this before. So let's use this in an example. So solve for x, and let's suppose we want to solve 2x squared minus 5x plus 3 equals 0. Now, maybe we could try to use our factoring trick here and get an answer, but I'll just warn you that if you try to do factoring, it's going to be a little bit tougher maybe than some of the previous factoring problems that we've done. So this is a perfect time to use a quadratic formula. So, solution. We want to solve 2x squared minus 5x, this is a minus, plus 3 equals 0. So this is our coefficient of x squared, so that's our a. This is our coefficient of x, that's our b. And this is our constant term, or c. So we write down, and again, I'm going to admonish you to write down formulas when you use them, just in their original form, just to make sure that this does two things. One, it helps you practice the formula, and two, it helps make sure that you don't make mistakes. So we're going to do negative b plus or minus the square root of b squared minus 4ac. And see how I put this little tail at the end here? I like that. That says here's the end of the square root, all divided by 2a. And now I just plug in my values of a, b, and c. So I've got a big division sign. Negative what? Negative 5 plus or minus, so this is giving us potentially two roots, the square root of b squared, so negative 5 quantity squared, minus 4 times a, so times 2, times c, times 3. This is all under the square root, and this is all on top of 2 times whatever a was. Well, a was 2. So let's start simplifying. Minus a negative 5 gives me a positive 5, plus or minus the square root of, now I've got negative 5 squared becomes 25, 4 times 2 times 3. Well, 4 times 2 is 8, 8 times 3 is 24, so I've got 25 minus 24. Isn't that nice? All divided by 4. Let's continue. I've got 5 plus or minus the square root of 1 divided by 4. This is going to be, well, the square root of 1 is just going to be 1. So we've got 5 plus or minus 1 over 4. And you can leave your answer like that if you'd like, or if you insist, you can say x equals, well, 5 plus 1 over 4 is 3 halves. 5 minus 1 over 4 is going to be 1. So you can answer like that as well if you'd like. And that's just a quick example of the quadratic formula. All right, let's do another example. So this one's going to be a little bit more involved, and this is going to be kind of word problem-y, but this is going to touch on the facts about parabolas that I'd like for you to know. So find the dimensions of a rectangular fence that maximizes the area if I have 18 feet of fence, and I can use the side of my house as one of the walls. Okay, so what we're going to want to do here is we're going to want to take this situation and write it as an equation, and we're going to try to figure out some things that the graph of this equation would do for us. Okay, so let's try to figure out what I've got. Well, first let's draw a picture. So I've got the side of my house, and then I've got these three pieces of fence. Now I've got a rectangular fence, and this fence is so long, that's a cursive L, and it's so wide. Okay, so it's L in length and W in width, and remember this is the side of my house. So we don't count this. But I need a large area, and I've got this length of fence used twice and this length of fence used once. So take a second and try to come up with equations that would describe both the area and the length of fence as they've been written in the problem statement. So what I'm looking for is the area is going to be the length times the width, and the perimeter is going to be 2W plus L. So the perimeter is going to be the total length of fence here. Now you might say, well, the perimeter of the rectangle is going to be 2L plus 2W, right? We've got the perimeter of the rectangle also involves that, but in this case, the perimeter of the length of fence. Now I happen to know that we've got 18 feet of fence. So we have 18 equals P equals 2W plus L. And I can solve this for L. So I get that L equals 18 minus 2W. And now I know the area in terms of L and W, but I can write L in terms of W, so I get that the area is equal to L, which is 18 minus 2W, times W. So that's times, that's minus. Let me write this a little bit, let me simplify this, and this is negative 2W squared plus 18W. Now what we're looking for, actually let me just copy this and move this over to the next page. I'm kind of running out of room. Now what we're looking for is some way to make this area as big as possible. If I were to sketch a graph of this thing right here, what I would get is a parabola. Now we're not really worried too much about sketching graphs just yet, but because you should have seen something like this before, let's see roughly what this is going to look like. Well, if I factor out a W again, kind of like we had here, I've got W times 2W minus 18. And when does this equal 0? Well, this equals 0 when W equals 0, again using the zero product property. This equals 0 when 2W equals 18, that is when W equals 9. So I know that this parabola has zeros at 0 and 9, and because the area should be positive, I'm expecting the parabola to go up above here. So as the width changes from width, if the width here was 0, right, then the area would be 0. And if the width here becomes 9, then I've used all my fencing on the width sides. So between 0 and 9, I should have some shape. It's going to turn out that I've got a parabola. Well, the maximum area is going to be this value right here. So you may have seen this formula for the vertex of a parabola. And the vertex of a parabola, so the x-coordinate of the vertex, or extreme point, of a parabola is minus b over 2a. And right now you've got a choice, right? If you've never seen this before, you're like, okay, hold on. We had L and W, and now we had a capital A and capital P show up, and now you've got a B and an A. Like, there are so many letters flying around here. Let's hold off. This is going to be the minus b over 2a from this form of the parabola. So when we simplified the parabola, we have our a here, and we've got our b here. So in our case, we have minus b over 2a is equal to negative 18 over 2 times negative 2. In this case, well, that's the minus signs are going to cancel, and we're going to have 18 over 2 is 9, so I've got 9 halves. Right? That 9 looks a little funky. Let me clean up that 9 a little bit. So what is the deal? What's going on here? Well, when w equals 9 halves, which in this case happens to be halfway between here, when w equals 9 halves, because I know something about the parabola, that means that this is the highest point on the parabola. So the area is maximized when w equals 9 halves. So the area is going to be, well, 18 minus 2 times 9 halves, 2 times w times 9 halves. So times w again. I just copied down this equation. Well, 9 halves times 2 is just 9. So this becomes 18 minus 9 times 9 over 2. So 18 minus 9 is 9, and this becomes 81 over 2. And that's going to be our maximum area. What are the dimensions? Well, here is my value for w, and what was L? We go back over here. Remember, L is 18 minus 2w. Let's copy this. Paste it here. 18 minus 2w. Oopsie. So this is 18 minus 2 times, remember, w is 9 halves, or 9. So the dimensions are w equals 9 halves. That is a terrible 9. I've been having trouble with my 9s. W is 9 halves. L is 9. And if you want, you can say that the area is 81 over 2. I'm really looking for these two, but this is nice to include as well. Okay, so to review, quadratic formula, which hopefully you've seen the quadratic formula before. It is this thing. Here's how you use the quadratic formula, and that's probably review. This might not be review, so this is a word problem. I'm asking you to do something that involves taking in natural language and translating it to, in this case, just an image really helps, and then translating that image to these equations. In order to analyze these equations, we needed to know some facts about parabolas. In this case, we just needed to know the vertex of a parabola. Now, the zeros of the parabola, knowing where these were, that helped. Just helped us sketch a graph. Don't stress too much about this. Hopefully you know how to do this, but don't stress too much about it if you're not super comfortable with it just yet. Also, this, if you haven't seen it before, I'd be happy to talk about it, but this is something that I'm hopeful that you've at least seen this type of thing before. Anyways, the big idea here was we drew a picture. That picture gave us some equations. We solved our equations. We had a system of 2 equations and 2 unknowns. We solved our equations and got the area in terms of one of them, and then to find where that area got maximized, we used the x-coordinate of the vertex of a parabola. That gave us our width that would maximize our area, and then we plugged back in to find what that area would be, what that length would be, and this is what I would consider the dimensions. The area is also nice to include. This is just kind of a check to make sure you're not getting like a negative area or something. Okay, thanks.